Hello there once again. Thank you so very much for joining us here on my channel, Lubama Hamza, for mathematics and physics. But today we are still in mathematics. And today I'm here to share with you integrals of the kind which require solutions in terms of natural log. So today's lesson we are looking at integrals with solutions in terms of natural logarithms. So in this sense, we shall need to know when do we attain such solutions. If you have been watching some of our videos, we must have seen a definition of the kind that if you differentiate natural log of a function, you would get 1, the derivative of that function divided by the original function. If you cross multiply the dx, you'll get the derivative of natural log of a function is equal to the derivative of the original function over the original function with respect to x. Then you introduce integrals. This means that if you have an integral of the kind which is a derivative over the original function where the derivative came from, then the answer is going to be integral of d of a function. You get that very function. So the answer will always be natural log of the original function plus a constant. Also, this can be realized from the concept of change of variable, as we shall be seeing in the different examples. Change of variable can guide us to lead us to this solution. But if you know, or if you can see the question in this sense, straight away you can write the answer as that. So we can have example 1. Integrate cot of x dx, whereby this is the same as integral of cos of x out of sine of x dx. Now if you know the derivative of sine, the derivative of sine is cos. It means the original function was sine. So straight away the answer is going to be natural log of the denominator, which is sine, according to this relationship. Now, what if you are not sure about that? You do not know whether that is really true. How do you go about it? You can go for method 2 by letting the denominator be u. So you let sine of x be u. So that du is equal to cos of x dx. So cos of x dx is the numerator. When I substitute, I'll have integral of du out of u, which is the integral of 1 out of u. Now the integral of 1 out of u, actually the answer is natural log of u plus a constant. It is from here that the integral of cot of x dx is actually going to be natural log of sine of x plus a constant. Now, where does the integral of du over u come from to give us natural log of u? If I may take that as example 2, then I'll need to remind you about the following. That from differentiation, we have seen the following. The derivative with respect to x of natural log of x, the answer is you first differentiate the x, you get 1. Divide by the original function, you get 1 over x. Okay? So if I may look for the integral of 1 over x, then I would cross multiply and I'll have d natural log of x is equal to 1 dx over x. Then I introduce the integral notation. So this is the question, integral of 1 over x dx. 1 is a derivative of x, so it is in the form of a derivative over the original function. So therefore, the answer is integral of d of a function. You get that very function. The answer is natural log of x plus a constant. So that is how actually the integral of 1 over u du became natural log of u. So if you do not know how the ln of x comes about after integrating 1 over x, I've showed you, you can use the change of variable and you can have it and you introduce it. So with that, we have had example 2. We can have example 3. Example 3 is integral of x out of x squared plus 1 dx. Now, the numerator has x, which is linear. The denominator is quadratic. But when you differentiate a quadratic function, you get a linear function. But now this linear function is missing a constant of differentiation, 2. So what do? Because I cannot easily see it, I use substitution. So you let u be the denominator, which is x squared plus 1, so that du is equal to 2x dx. Then this would mean that x dx is actually a half du. Then it is from this note that I'll substitute, where I have x dx, which is a half du, over u, which is the integral of 1 over u, which answer is a half natural log of u plus a constant. So when I substitute back, I will have integral of x over x squared plus 1 dx. The answer will be a half natural log of x squared plus 1 plus a constant, which brings out what the definition states. But in this case, there was a missing a half. Missing it 2. That missing it 2 now, because of integration, it is divided off. The evidence comes from the method of using change of variable to differentiate that, and then it will take us to bring that constant which is missing. So if it is in any other form, for example, they can give you a number like this one now. They give you another form of the number. That's example 3. But if they give you integral of x squared out of x cubed plus 1 dx, then here comfortably you see x squared comes from the derivative of what? X cubed. But because the 3 is missing, we divide it off because of integration. Then natural log of the denominator plus a constant. So if you want to come to this, you can strictly go and use the method of change of variable, and you derive and you see that you can realize that answer. How about this was example what? 3, 4. This is 4. Then example 5. Integral of 1 out of 1 minus 2x dx. The same will apply here. When you differentiate 2x a negative, you get a negative 2. But the 2 is missing, even the negative is missing. So because of integration, you will divide them off, which is 1 over negative 2. Then natural log of the answer. Now, sometimes when people don't follow this bracket of the definition, which I mentioned earlier in the beginning of the video, we can always use method 2, which is letting u be 1 minus 2x. So that du of dx is equal to a negative 2 dx. Negative 2 only. So you can make dx the subject, and in that case dx is equal to a negative du over 2. When you substitute, you'll have integral of 1 over 2 over u, this is 1 over u, times a negative du over 2, which will be the integral of a negative a half of du out of u, which will give us a negative natural log of u out of 2, which is a half. And when you substitute up there, that's how the answer will become a negative a half natural log of 1 minus 2x plus a constant. So whenever there is a minus or the x has a negative attached to it, don't just rush and write the answer. When people rush like this, because they already know the definition of the formula, sometimes they miss out on the negative. But if you let and you substitute and use the change of variable, straight away, just know that you cannot easily go wrong with the negatives as expected. If I can proceed, let me give you example 6, which is integral of x squared exponential of x cubed dx, whereby this is a derivative coming from x cubed. So you can either let u be x cubed, so that you have du is equal to 3x squared dx. Then you make x squared dx the subject. Then it means the integral will become e of u times a third of du. And the answer will be a third exponential u plus a constant. It is from this note that you get a third e of x cubed plus a constant. Meaning, if you have an integral of a derivative of a function, exponential that original function with respect to dx, then the answer is going to be exponential that very function plus a constant. If there is a missing value or a missing constant attached to the derivative, then because of integration you divide it off. That's why here there was no 3, it was missing, but after changing variable the 3 came through as a division, which division matches what we call the integrals of functions, which increase the power. Then lastly, for the learners, try out this one. Integral of 2x out of 3 minus 4x squared dx. Thank you so much for joining us. Make sure you try out this number, share your solution in the comment section, and always keep sharing the videos, keep liking it, keep it here at Rubama Hamza. Subscribe. Thank you so much.